Hello, my name's Zachary Weiss. I'm a first year grad student here talking about what my research is at the Soybean Breeding Lab here at Virginia Tech. And this presentation is about predicting agronomic traits in soybean. So, first of all, who am I? My name is Zachary Weiss. I got a BS in computer science from Virginia Tech with a minor in philosophy. My birthday is April 6th, 2002, and I'm pursuing a master's in science in crop and soil environmental science. My research is in phenomic prediction of agronomic traits in soybean, and some of my life goals are to own a farm and to grow my own food, and also I want a dog. So, why should you care about my project? Well, monoculture has often seen variable yields in the most recent decades, and farmers can't use USDA data in its current form because the data is in PDF format, and it's really hard to figure out what the trends are and if there are any specific varieties that are doing well or better than their competition. And breeders and farmers can predict from phenomic yield prediction. And right now, the USDA funded research or the USDA research that's publicly funded is inaccessible to the average person who doesn't want to go on their website and scrape through PDF data. You can find the information at this link below. And I did my research on the southern states from 2023 to 2014. So, what can we learn? This is a graph that I was able to produce with the data that I have, and the green to red shows trends and predicted areas for that latitude and longitude. So there are over 7.5 thousand individual samples that I've collected, trained a model on. It's a 73% accurate random forest model with an average yield of 54 bushels per acre that the model predicts. There are 44 features on this data set with 27 plus unique locations. And I have 10 years of data. So some historical trends this is yield. So you see the blue line is hovering just below and actually crests 60 bushels per acre for each year. So you can see that the trend is pretty good, and that um, the max and the min vary as well with a oh with a around 40 to 60 uh, bushels per acre range in between the min and the max yield. So we have height is one of those features that is often recorded in in the USDA trials, and you can see that most often you'll have plant height that's just under 30 inches to ranging around 3 feet tall is where you'll have the highest, well, not the highest yield, but the most average for the typical yield for soybeans. So figure four, it's this is showing off the seed size, comparing that to yield. So you have a big group around 14 grams per 100 seeds, and you can also see that at the higher range of yield, you have around 15 grams per 100 seeds, if not a little bit more. So those are typically seen by like the larger seeds versus the smaller seeds, which are typically under to at 10 grams per 100 seeds. And we have something that's very important to note is that row spacing and planted length have a huge impact on how much crops can actually grow. So this graph here shows the difference between planted length and row spacing, comparing that to the highest yielders. This graph is very important for any kind of grower that wants to see if there's a way that they can change it up for next year if they're growing soybeans. That graph again, but it's a kernel density estimation, which is essentially taking two values and then weighting them against another. So the weight is yield, and you can see that the highest yielding varieties are actually at this row spacing of 1 to 2 feet with a planted length of like just under 2 feet. Or no, it's just over 1 foot of the planted length. So there's some interesting information here that a breeder or a farmer would want to know. So here's another graph that I think is really interesting. So the varieties have little names in front of them that show their origin. So you can actually see, based on yield, how each variety does over the years, over the 10 years. So you can see the legend is on the right. See the V is Virginia varieties, and you can see how they've changed over the years. Same thing with the UA. They're both blue. And we have oil percentage trends. So some of the agronomic goals of breeding has been increase oil percentage since 2024, and that is pretty evident. It's definitely needing to increase and has stayed constant over the past 10 years. And protein percentage has only been recently tracked by the USDA since 2018. So we have this similar consistent variable or consistent with variable bounds protein percentage within seeds, which goes just underneath 50% at 13% moisture content, while oil was around 20 to 30. So the discussion. So the best planting conditions could be 4 square feet plots with 1 to 2 feet in between them. And the height goals for the best yield are 2.5 to 4 feet tall. Some varieties like AG or NC varieties are probably best cross location for performance based on the trends that we saw in that last graph. So it's now a little bit easier to understand the USDA data based on my research. And I have a website tool that's in the making that will allow you to query by zip code location to see how much you could potentially grow within an acre of field planted soybean. So right now, out of the 80 years that I collected data from in the southern states, that's 10 down. There are 70 left to go, and that's not even counting the northern states. So in conclusion, soybean breeding for agronomic traits can be better enhanced by the collection of USDA uniform trial data, but more work is needed for accurate modeling. We still need the northern states trials to get a better product out of this research. And this is just the first steps. There's already promising information about growing for higher yields that can be determined from this research. And I have high hopes for the future of this information collection. We still have 70 years, guys. 70 years. So yeah, thank you for listening. Hope you have a good one.